Okay, so I'm starting in 3, 2, 1. So hello and welcome to the GEO-Academy webinar number 5. I'm Gustavo Rojas from Núcleo, and today we'll be presenting the GEO-Kit, which is one of the main outcomes of the GEO-Academy Teacher Academy. Alongside me, I have our host, Shana Sontag from Eurizi and Lucas Katsikas from NTUA in Greece. And also here by my side is my colleague, Luis Costa from Núcleo, that will be helping me with the demonstration of the GEO-Kit. So I'm going to share my screen and we are going to have some interesting presentations. Let me just find here the window. This is the button. Yeah. So it all starts in the GEO-Academy website. So that's geoacademy.eu. It's your point of interest to everything related to GEO-Academy. And if you look here at the right-hand side, you have a hot link for the GEOBSERVE platform, where is all the pedagogical content and resources is available. You can also go straight to portal.geoacademy.eu, and there you'll find our GEOBSERVE platform. Here you can find resources and tools that were created by the collaboration, the GeoHubs, which are the communities, the international community and the national communities, where you can meet fellow teachers and share your experiences on environmental and geographic education. You have the e-modules, which are online courses on several topics related to the geo topics that GEO-Academy has prepared. You have some sessions on events and news. And particularly for this presentation today, we are going to explore the e-modules related to robotics and coding. More of that in a minute. In order to access the e-modules, you need to register for the platform. So if you visit the portal, you have the login option on the right. And when you click in login, you'll be directed to this screen. So this screen, if you already have an account, just enter your username and password. But if you don't have an account, you need to register. So you need to select register to create your account, and that will bring up the registration screen where you need to fill your personal details and create your account. After you create your account, you will receive a confirmation email, and then you will be able to access the full content of the GEOBSERVE platform. One important note is that you need to have your cookies active for accessing the portal. Otherwise, you won't be able to complete the registration. So please accept all cookies. If you, by mistake, you reject cookies, you can scroll down up to the bottom of the page. And here, if you click on cookie policy, you'll be asked again if you want to accept the cookies, and please do so. Also, you need to click on this capture here by the end to confirm the registration. If you don't see this button, please accept cookies and reload, and you will be able to register. So after you complete your registration and login, you can access the full content. So now here I'm logged in my account. And what we are interested today are the activities related to the GeoKit, which we will show very briefly in a moment. So these are all concentrated here in the GeoHubs section of the GeoBServe platform. If we go here on GeoHubs, you see a map of the different geotopics that are related to the different courses and activities. It's a bit slow here, but eventually we will see. It's not the GeoHubs, sorry, it's the e-modules. The GeoHubs are the communities, sorry by my mistake, but here you can find the GeoHubs, the different national communities, and in the e-module sections, you will have a menu of different geotopics that will lead us to the specific courses. So today, as we are talking about the GeoKit, we will be using this geotopic, which is coding for urban sustainability. And here, if you click on that button, we have here 10 different courses that you can use to explore this geotopic. In particular, we have some topics here, there's some courses that use the GEO-Kit. So after we show the GEO-Kit, we are going to explore more closely this activity here, this course, which is building a seismometer. But right now, I'd like to ask Luis to help me in presenting the components of the GEO-Kit. So, Shana, if you can pin um, the other camera, is it working, Luis?
Yeah.
Yes. Okay. So the GEO-Kit was prepared by the GEO-Academy consortium, and it includes several sensors and microcontrollers that will allow your students to collect data and learn more about environmental topics and also related to the special locations where this data is collected. So it's a very powerful tool to have some interesting experiments in the classroom, and also promote learning coding, because to have these microcontrollers working, you need to code them. So on the bottom row that Luis is showing now, we have two different types of controllers that we use. The first one is the Arduino, which is very well known. So we have some sensors that will work with the Arduino. And by the side, we have each GeoKit has two microbit controllers. And today in the activity, we'll be using both at the same time. So this is a different type of microcontroller, the microbit, which is very versatile and very easy to use. So in the GeoKit, you have therefore three microcontrollers, one Arduino and two microbits. The microbits, they come with the cables to connect, and also the power pack that allows the use of the microbit uh, away from the computer. So it's the power source. There, Luis is showing the connection cables, the standard USB connections for Arduino and for the microbit. And now here on the bottom right, we have the expansion modules. So we have two expansion modules for the microbit that allows integrating the sensors and the other components in Arduino and in microbit. Now, moving up to the next row, we have this. This is a case of the microbit, where for the packaging, we'll see also the batteries, because the microbit can operate with batteries. And you also, can you show please again, there's an electric motor with a cord, and you soon you know why there's an electric motor and a cord incorporated in the GeoKit. Now moving to your left, Luis, we have another power source that comes with on and off button, and we have the power pack for the Arduino plus the cables that we already showed. And on the top row, we have the sensors. So we have different type of sensors. This one, I think, is the GPS module,
Yes.
right? Then we have the temperature sensor and humidity. There's the gas sensor. We also have a display module for
LEDs.
for LED sensors for the, I think that's for the Arduino. And finally, we have the breadboard that is to connect the different elements, plus several jumpers and resistors that are used to build the circuits. So everything comes inside a small plastic box, and each partner in GEO-Academy received such a GeoKit, and this is being used in the schools that where the teachers that participated in our trainings, they learned how to use this GeoKit and how to use it in their classes. So today, what we are going to use, and if you can already pick up the components, we use the two microbit sensors in the activity that for the seismometer. So why do we are using two? Because one will be the sensor itself that will collect the movement of the sensor to simulate if there's an earthquake, it will shake, and we'll register the movement, and we'll send the data to the second microbit, which is the receiver. And the receiver will transfer the information to the computer, and we can have real-time information about the shaking of the sensor. So this is going to be our activity, but before that, I'm going to talk very briefly about the other activities. So this is a very simple experiment that only needs two microbit sensors. So if your school already have these microbits, you can immediately start using this lesson plan, because you don't need the other components. But if you want to do the more sophisticated use of the GEO-Kits, then you need all those extra sensors that we presented, and this is explored in depth in the other activities. Okay, so thank you, Luis, for being my cameraman. I'll go back to the presentation. I'm still sharing, right? So let's now go back to the portal. So I started here, so we are going to explore this activity in a moment. But we have other activities that use the GEO-Kit. So this one, for instance, is a very interesting activity that is related to the air quality. So most of us live in urban areas, and we have lots of pollutions from industries, from vehicles. So it's interesting. It's an interesting project for the students to monitor themselves the air pollution, and this activity explains how you can use those sensors with your Arduino controller to have your own environmental air quality station. We have these other four activities that this one uses the GPS module on your Arduino sensor, or even on your phone, and how you can use the sensors to create a petty paper adventure, which is very popular with students, especially young ones. This is another interesting activity that touches the subject of sonification. That is how you represent data using sound. So both the Arduino and the microbits, they have speakers that can emit sounds, and then you can uh, use the sensors to collect the data, and the processor to uh, have the output of this data in form of sound. So this process is called sonification. And it's very interesting, not only for having the representation in different formats, but also it's very inclusive, because people who are visually impaired, they can now receive this information via sound and not via images as is usual. We have two more activities that were developed by Luis. One is about also climate monitoring. So we can use, for instance, the temperature and humidity sensor and relate this to agriculture. And finally, an activity that's about lighting efficiency. So this is very important these days, facing the environmental crisis that we are living in. We should be conscious about the use of energy, and this activity will address exactly how you can have a more sustainable way of lighting our living places and our offices. So these are the activities that use the GEO-Kit. There will be a few more coming before the end of the project. And you can explore them all in the e-module section of the GeoBServe portal. That being said, we are going to explore now in detail the building a seismometer activity. So this is a course, so you need to enroll the course. I'm already enrolled. So after you create your account, you log in on GeoBServe, you can go to the e-module, select the building a seismometer activity in the robotics GeoConcept, enroll it, and then you have here an overview of the course. You have the curriculum, and you have the materials. So in the curriculum is the index of the activities. So it is divided in two parts. We have a pedagogical component that is to help the teachers to to start this activity with the students, depending on the age of the students and also how much time the teacher has. And in materials, you can find the technical reference guide, which is the step-by-step guide on how to assemble that particular experiment and have it working on your computer. So that's what I'm going to show immediately now. So you can download the technical reference document and open on your own computer and check how you can have a seismometer with the microbits. So we are going to use the microbit sensors, and if you never use it, these sensors, these controllers, I highly recommend it because they are very versatile, very easy to use, and the students they love to work with it because it's so easy, and there are so many things that you can do it. And the most interesting part is that you don't even need a microbit to start learning about it, because uh, this is a product that is related to Microsoft, and you have, if you go to the main website, which is makecodes.microbits.org, you can emulate the microcontroller in your own computer. So how does it work? It works when you go to makecodes.microbits.org. You can create an account and you can immediately start working with the projects. So I'm going now to, so how you do it? You just go to sign in. You can create an account with your email, if you have a Microsoft account, or if you have a Google account, you can sign up. I already have an account, so I'm going to just use my Google account to continue using the Make Code platform. And how does it work? So the microbit, the microcontroller, it doesn't have any keyboard, it doesn't have a display. So it's very powerful, but you have to code in your computer, and when the code is ready, you transfer the code to the sensor. So that's how it works. And for this particular project, we need two codes. One code that for the sender, which is the sensor that will record the shaking, and another code for the receiver that will be on the connected to your computer in receiving the data. So you need to write two codes. Okay, and I already did that, but before going in that direction, I'm going to stop sharing and showing a step-by-step guide on how to do it. So meanwhile, Shana, Lucas, are there any questions from the audience, or should we continue? We can continue, right?
We
We
can
can
continue, yeah.
continue. Yes.
Okay, so I see Aphrodite is here. Hello, Aphrodite. So, okay, so I'm going to now change presentations so we can see a step-by-step guide. Again, this is all available on the GEOBSERVE platform in the course that I just showed. Oh, I need to share again. It's always okay, so where is it? Okay, I'm going to show you two things actually. So this thing here, what is it? Is the component list. So you will find on our website the component list for the GEO-Kit. So if you want to have a similar kit in your school, you can just purchase the same components. Maybe you have most of these elements already in your school. So GEO-Academy has this available for you. So you can have a similar kit in your school. And I'm going to share now again the activity itself, the activity guide, which is here. it's one, it is winter school, exactly. So this is the one that I want to show you. So this was an activity that we developed for the winter school that took place in Vienna early last year. So what we're going to use from the GEO-Kits, the hardware is very simple. We have the two sensors that I already mentioned. We need two battery packs. One is to power the sender because it will be elsewhere. And the other one is to power the electric motor that will produce different vibrations. So this number 5 here is very similar to number 4. The difference is it has a on-off switch that you can use to turn the motor on and off. There's also a cork. This is to dump the vibrations, and you can try different geometries of the cork connected to the axis of the electric motor. And you have an USB cable that you'll be using to connect the receiver to the computer where you see the data collected by the sender. So how do you work it? You go to your MakeCode account and you select new project. The first project that we'll code is very simple and is the sender code. Just let me just close here the thumbnails. No, it didn't work, but no problem. Okay, just want to. So we go to make code, you select a new project, and you are going to name this project sender. And in microbit and make code, you can code in different ways. If you know how to code, you can code directly in Python, or you can code in Java. But the easiest way, especially with students, is to use this visual type of coding. It's block coding. And you have on the left side of the coding different types of functions. What we have here, I'm going to do it step by step very shortly, is that we need to code the sender program to use its radio capabilities to record the movement and send the information by radio to the receiver. So we have two blocks of coding, and that's I'm going to show now the code itself on my account. I need to stop sharing again. Sorry, but I need to go back and forth the different windows. So now going back to the Microsoft Maker code. So let's have a look at the sender so we can check how it looks. So this is the code ready. I'm going just to show how we built it. On the left-hand side here, we see the emulation. So this is a simulation of how the microbit will react to this code. So we see everything is very simple because they are color-coded. So this blue part here, these are the basic elements. So the first block that I'm going to add is this one that is named on start. So I'm going to scroll down the options in blue code and I select here on start. And now we just follow the instructions. So on start means what happens when you start the controller. So I'm going to select now another basic function. It's called show string. I just look how simple it is. I just put it here and we'll click and now it fits. If it's a code that is not available, it won't fit here in this. It's like working with a puzzle. So for instance, if I want to have the forever block here inside, I cannot because it doesn't fit. It doesn't have all these curves. So the colors and shapes of the different blocks, they are very helpful to assemble the parts of the code. So the first thing here is that I want to tell the microcontroller that on start, I want the display on the microbit to display something. So here the default is hello, but I want here to say S because she is the sender. So when I start the button, it will show S, which is exactly what is appearing here. Then we have another element, which is pause. This tells me for how long it will show S. The default here is 1100 microseconds, but I want 1 second, and that is 1000 microseconds. So what it says is that on start, my display on the microbit will show the letter S for 1 second, and then will black out. And then I'm going to turn on its radio. So there's also this block here that is called radio, and I can get this block and put it down here. And this is like the channel. Which channel do you want to transmit your information? We have so many channels, but we are going to be very creative here and use just number one. So it's going to be number one. Yes, okay. So this says that I want my radio to broadcast on channel one, but I can choose any other channel, but then the receiver needs to listen in the same channel. And finally, I have clear screen. So it's a blue code. Where is it? It's here. So I just assembled exactly this code that was already ready here. You see? So it's just to show you how you assemble such code using make code. So it's very, very easy. You may have some difficulty in the start to understand where each function is, but just follow the colors, follow the shapes. It's very intuitive, and then you can build your own code. So that's how I built the first code. I'm going to delete it. Now let's very quickly do the second part. So this is on start. So this is when you start and runs only once. And the forever, it's a loop that will be running as long as the microcontroller is active. So this will be the radio transmission. So you see this is red. Red is radio. So I'm going to select radio. And if here, I want the function that is called radio send value equals. So it is this guy here, radio send value equals. But what do I want to send exactly? So we have two fields here that we need to take care of. First one is name. What is name? Is the name of the variable. So what I'm trying to do now is to tell the radio emitter to send me the acceleration on different axes. So I have three axes. I have the horizontal axis, X. I have the vertical axis, Y, and the other axis that is perpendicular to the other two, that's Z. So I'm going to have three different radio send value blocks, one for each axis. So let's put them here. And I'm calling the first one X, the second one Y, and the third one is Z. But I need to tell what is X, what is Y, and what is Z. It can be anything that the sensor is recording. I want to send the acceleration values. So where is it? It's in input. You see, this is like pink. So this is input, and I'm going to search here. You see there are many inputs that we can transmit. I can, for instance, transmit the light level for a certain variable. I can send temperature. I can send the heading, uh, because these are all values that the microbit sensor can sense. But in this particular case, I'm interested in the acceleration, so I'm going to move this guy here Is it like that? Yes, okay, good. So I have now the acceleration as the variable that I'm calling x, and I must be sure that is the acceleration in the corresponding axis. So this is okay, and I need to do the same for the other two axes. So I'm going to select here acceleration again, but now for the axis y, and finally the same for the axis z. What I want to highlight here is that if you can notice, we have two different shapes of inputs. We have inputs that are oval, right? And the input that is has sharp edge for the buttons. So if I want to put this button express it in this variable, I won't be able to, because it's not a kind of variable that is compatible with this type of memory. So if I try to do something that is impossible, it won't work. So this is also very helpful when you are learning how to code